Hello everyone, welcome back to my YouTube channel Exploration with Sejal. So today we are going to start with vector integral calculus. So under vector integral calculus we have line integral, surface integral and the volume integral. So line integral is given by integral of from a to b v dot dl, where dl is the infinitesimal displacement vector. For surface integral, we have integral for the surface v dot dA, where dA is the infinitesimal surface area element, and for volume integral, we have this integral of tau v dot d tau, where tau is the infinitesimal volume element. So these are the symbols for the closed integrals. Now let's see what is the line integral. A line integral has the expression of the form integral from a to b v dot dl, where v is the vector function and dl is the infinitesimal displacement vector. So for a closed loop, this is the symbol we write, and if a closed integral v dot dl is equal to 0, that means the vector is said to be conservative. That means the integral is independent of the path and determined entirely by the endpoints. Now let's see an example from Griffith, that is example 1.6. Calculate the line integral of the function v is equal to y square x cap plus 2x y plus 1 y cap from point A to B. So here we have point A, that is 1, 1, and we have point B, that is 2, 2. And we have to find the line integral along path A and path B. So this is the path 1 which I am talking about, and this is the path 2. So before I solve this, I recommend you to pause the video and try to solve by yourself. Okay, I hope you have solved by yourself and you are just checking the answer. And if you are not able to find the answer, here is the solution. So we consider path 1, that is this path, that is 1, 1 to 2, 1. So this is like path 1's first part, and here we see from 1 to 2, y goes from x goes from 1 to 2, y is 1, so y is constant, that means dy is equal to 0. So we get here v dot dl is equal to y square dx plus 2x y plus 1 dy. So since dy is equal to 0 here, we put it 0. So y is equal to 1, so we put it as 1, and we integrate it from 1 to 2. So here we get it as 1. Now let's do path 1's second part, that is 2, 2 to 2, 1 to 2, 2. So here we see x is equal to 2. So change in x is equal to 0, that is dx is equal to 0, and y goes from 1 to 2. So here we write dx is equal to 0 and 2x y plus 1 dy. So what we do here is that we just write the value of x here and we integrate it from 1 to 2 over dy. So we integrate this, this becomes 4 y square plus 2 plus y from 0 to 2, and we substitute here and we get the answer as 10. So we get for path 1 integral of from a to b v dot dl is 1 plus 10, that is equal to 11. Now let's see the path 2. So for path 2 we see that x is equal to y, so dx is equal to dy. So we substitute this x is equal to y and dx equal to dy here, and what we get is this. So it's 3x square plus 2x dx, and we integrate this. This becomes 3x cube by 3 plus 2x square by 2, and this becomes x cube plus x square, limit goes from 1 to 2. So we substitute and we get the answer as 10. So we see that the closed integral v dot dl is equal to 11 minus 10, that is equal to 1. So we see that closed integral v dot dl is not equal to 0. That means v is not conservative.